Now, if z is expressed implicitly, or if the function is expressed implicitly, that is for f of x, y, z is equal to 0 at x naught, y naught, z naught, then the equation for my tangent plane to the surface at this point is going to be fx at x naught, y naught, z naught, x minus x naught, plus fy at x naught, y naught, z naught, y minus y naught, plus fz at x naught, y naught, z naught, z minus z naught, it's equal to 0. Is equal to 0. So we'll look at an example for, find the equation of a tangent plane to this surface, f of x, y, z is equal to x squared plus y squared plus z squared at the point forgive me, the surface is x squared plus y squared plus z squared is equal to 30 at the point 1 minus 2, 5. At the point 1 minus 2, 5. Okay. So now, we need fx, fy, and fz, right? From that. So, fx is 2x, fy is 2y, and fz is 2z. I hope you can see when we differentiate the function, right? Okay. Now, at fx at 1 minus 2, 5. In place of x, we put 1. I have 2. Fy at 1 minus 2, 5 is minus 4. And fz at 1 minus 2 and 5 is 20. No, it's 10. When I put 5, I get 10. Okay, so 10. So I'm good to go. Okay, I'm good to go. Let me clean this. So the equation of a tangent plane to the surface, we are going to follow just that, right? Is fx at the point. Now fx at the point is 2. X minus x naught is 1. Plus fy at the point. Fy at the point is minus 4. So I get minus 4. Multiplying y minus y naught. Y naught is 2. Minus 2, so I get plus 2. Plus fz at the point. Now fz at the point is 10. Z minus z naught. Now z naught is 5. So z minus 5 is equal to 0. Now this is the equation of our tangent plane. Our tangent plane. Our tangent plane to the surface. Right. You can simplify. That should not be a problem. Okay. Now, we also call this linear approximation, and it's the same. The equation of a tangent plane, okay, is going to be the linear approximation to the surface at the point. Now, you know, it's sometimes we want to just approximate. Approximate is at the point of a surface. We will not want to use the surface. So we want to use a plane to approximate the surface. If there's a tangent plane, it's very big, right? But if I don't want to use all these equations, or the surface, and I'm at a point, right? Then I can just use this small plane here. In place of the surface, right? In place of the surface, I'm going to use this plane, right? So we call this linear approximation. We use the equation of a tangent plane to approximate a surface at a point, right? So this is the same as linear approximation. So if you are asked to find linear approximation to a surface at a point, it's going to be my linear notation, x, y, and an approximation. So it's going to be like this, right? Then I'll write 2x minus 1 minus 4 y plus 2 plus 10 z minus 5 is equal to 0. Okay, that is linear approximation. Okay, now we can also find the equation of a tangent line. So of a normal line. Now normal line meets a plane at the set point at 90 degrees, right? Okay. Now this is the equation for a normal line. Very, very simple equation. Very, very simple equation. Okay, now the equation for a normal line is given by the line, right? And it's in a parametric form. Parametric form. We just press it in terms of a parameter t. That's what we mean by parametric, right? Okay. R of t is equal to x naught, y naught, z naught plus t multiplying grad f at x naught, y naught, z naught. That's all. T multiplying grad f at x naught, y naught, z naught. Now, simply let's look at the equation of the tangent plane to x squared, so normal line to x squared plus y squared plus z squared is equal to 30 at 1 minus 2, 5. At the point 1 minus 2, 5. Now, what we need here is our grad f. And what is our grad f? We said grad f is equal to fx, fy, and fz. Now, so my grad f, if I differentiate this function with respect to x, I get 2x, 2y, and 2z. So grad f at 1 minus 2, 5 is in place of x I put 1, so I get 2, comma, place of y minus 2, so minus 4, in place of z 5, so 10. Okay, so my equation of my line, of my normal line, right, is just the point expressed in vector form. So I'm going to write 1 minus 2, 5 plus t multiplying 2 minus 4 and 10. And that's all. And here we simplify. Okay, I have RT alright, RT is equal to 1 minus 2, 5 plus 2t minus 4t and 10t. It's a vector, so I can add them. So I write RT is equal to 1 plus 2t minus 2 minus 4t and 5 plus 10t. If you do not get this, right, let me do it at the top one last time so you see. You see, because it's a vector, I want to start from RT is equal to 1 minus 2, 5 plus 2t minus 4t and 10t. This could be written as I minus 2j plus 5k plus 2ti minus 4tj plus 10tk. So we group all the i's, group all the j's, and group all the k's. So I'm going to get 1 plus 2ti plus minus 2 minus 4tj plus 2 plus, it's 5, 5 plus 10tk. This is the equation of a normal line. Either this or either this. Either of them is accepted, right? This is the equation for the normal line. Okay, so we just saw the equation of the tangent plane to a surface and the equation tangent plane at a point to a surface. And we also saw the equation of a normal line to a plane at the point of a surface. Okay.